Hello, this is Ms. Clausing. Okay, so let's do Unit Unit 5, Day 6 video Part 2. So we split this into two videos. So the first video we talked about transformations, and now we're going to talk about inverses of radical functions. Okay, so remember at the beginning of the year we briefly talked about inverses. All you do to find the inverse of a linear function is you switch your x and your y. So let's just do this little example right here at the top that shows that. So I'm going to switch my x and y. So my x will become x equals 3y plus 5. Okay, and then I'm going to solve back to get y by itself. So to get y by itself, I first need to subtract 5 from both sides. So this will give me x minus 5 equals 3y. I need to get y by itself, so now I'm going to divide by 3 on both sides. So this gets me to y equals x minus 5 divided by 3, which can also be written as y equals 1/3 x minus 5/3. Okay, I can split that 3 because both parts of my numerator are being divided by 3, so I can split it up into both pieces. Okay, so then this is the inverse, which is indicated by a -1. So y to the -1 indicates that this is the inverse of this original function here. Okay. Okay, so we're going to use all those tools we've been learning this unit to solve radical equations, to find inverse of functions. Okay, so of more nonlinear equations. All right, so let's start with A. So on A, same kind of concept, except remember I've been saying all year, when you see f of x, kind of treat it like y. So first thing I'm going to do is I'm going to just write over this and put y equals. Okay? Now that I have y equals something, I can switch my x and my y. So I'm going to just switch them. Okay, so now I have x equals y minus 2 cubed plus 1. Okay, now I need to solve back for y. This is where all those tools we've been learning in days 1 through 4 for solving radical and exponential equations are going to come into handy. Okay, so remember last class we talked about solving radical and exponential equations. When I have my y, it's being trapped by the 3 exponent. I first need to get my move my 1 to the other side, and then I can get my y free. So I'm going to move 1 first. So I get x minus 1 equals y minus 2 cubed. Again, I need to get y free from the exponent of 3. So I'm going to do the opposite. If I have an exponent of 3, the opposite of that is going to be taking the cube root. What I do to one side, I have to do to both sides. So I will end up with the cube root of x minus 1 equals, and my cube root and my radical cancel on the right and leave me with y minus 2. So now my y is free, but I still need to get y by itself. So I need to move this 2 over, so I'm going to add 2 to both sides. So I'm going to end up with the cube root x minus 1 plus 2 outside the radical, and then equals y. Okay, so let's just switch this around. I'm going to put the y over here because that's how we're used to seeing it. Y equals the cube root x minus 1 plus 2. Okay, and this is the inverse of the original function. All right, so just to review what we did in the last video, even though it doesn't ask us to do that here. My transformations here. I have a cube root function. My transformation, my x minus 1. The number hanging out with my x is my x-axis shift of plus 1, because the x-axis is the opposite of what it says. And then my y-axis shift of plus 2, because my y-axis does exactly what it says it's going to do. All right. So the inverse function, I know that if I go back to page 1 of my notes from part 1 video, I know that when I'm taking, remember here, we're taking, too far. We're taking the cube root. So I go back and look at the parent function of a cube root graph. And I notice it's kind of like in the middle here, it's the B, and it's like a sideways, kind of looks like an S, right? It goes through the origin, 1, 1, -1, -1. All right, so that's what it looks like. So I could just roughly sketch down here. Again, this is just practicing what we learned last time. I could roughly sketch this x-axis, y-axis. Knowing my parent function starts at the origin, so my inverse function is going to shift on the x-axis +1, and on the y-axis +2. So it will change directions right there, and it will look something similar. It'll have the same shape as the parent function, so something like this. Okay? All right. So inverse. So let's see. All right, I want you to pause the video and try B. B is very similar to, well, actually, no, we'll do B together. Okay, let's do B. So B, similar concept. Remember, think of f of x as y. All of it, not just the f. The whole thing is y. And I'm going to switch my x and y. So I have x equals the cube root of y plus 4 minus 7. So we're going to have to use those tools we learned last time to solving radical equations to try and get that y free. Okay, so first thing I'm going to do is I'm going to add 7. Get anything away from my radical I can. So I have x plus 7 equals the cube root of y plus 4. And now I want to try and get y free. So I'm going to have a cube root, so I want to do the opposite of that. So I'm going to cube this. What I do to one side, I have to do to both sides. Okay, so now I have x plus 7 cubed equals my radical and my cube cancel on the right and leave me with my freed y plus 4. All right, so now I want to get y by itself, so I'm just going to do minus 4 from both sides. So I have x plus 7 cubed minus 4 equals y. Okay. All right, so now I'm going to, now this is my inverse. This is basically my inverse of this original function. Now I could rewrite this and put my y over here, which is how we're used to seeing it. The -1 indicates it's an inverse. And then put my x plus 7. I'm not changing anything, I'm just rewriting it so it's a little prettier and how we're used to seeing it. Okay. Again, we won't do it this time, but you could also figure out your transformations on this inverse too. Okay, so now let's talk about C. Okay. All right, switch back to green. Just switch off colors so it's easier to figure out between the two. All right, again, just make this y, switch my x and y, and then solve back for y. So I have x equals 5y squared plus 4. Okay, I'm going to write these steps down at the top just so you have them. So number 1, you switch x and y. Step 2, solve for y. That's all we're doing when we're finding inverses. Okay, those are your steps. Okay, so C. Alright, so I need to solve back for y. So first thing I'm going to do is I'm going to move this 4 over to the other side. I'm trying to get y by itself. So I have x minus 4 on the left equals 5y squared. Okay, and then I need to get y by itself as best I can, but first I need to move this 5 over. It's 5 times y, so I'm going to divide by y, or divide by 5 on both sides. So then my 5's on the right will cancel, leaves me with x minus 4 over 5 equals y squared. The opposite of squaring something, so I want to get y by itself. So the opposite of squaring something is taking the square root. So to get rid of that square, I need to take the square root of both sides. Okay, so this will leave me with my radical and my square will cancel on the right, which is what I was trying to do. And I end up with a square root. Since it's a square root, I don't have to write the 2 in the little as the index, so I can just write square root of x minus 4 over 5. And that's my inverse. Okay? Again, you can switch it around like we did for A and B and put y on the left and everything else on the right. Doesn't really matter, but anyways. Okay, so D I'm going to leave for class. So we'll talk about D in class together. You don't need to do D on your own. We'll do it together in class. Okay, let's move on. Okay, so what I want you to do now is I want you to try and bring to class with you A, C, and D. Okay, so you try those three. Again, B we'll do together. A, C, and D, I want you to try those. All you're doing is finding the inverse of each relation or function. Okay, and then down here is just a little bit of review. All you're doing is listing the transformations to each parent function, state the domain and range. So I'm just reading the instructions right here. Listing transformations, stating the domain and range. Okay, so the easiest thing to do first is let's go back and look at our parent functions. All right, those are on page 1 of our notes here. Notice when I have x cubed, a function on A, right here, let's see, we'll use blue. For this one, f of x equals x cubed, and for this one, y equals cube root of x, notice my domain and range are always going to be negative infinity to infinity. Always. No matter what transformations I have, no matter what, they're always negative infinity to infinity. So let's go to this last page and just quickly fill in the domain and range for any time I see an x raised to the power of 3 or I see a cube root of x. Okay? So, again, you could type all these in your calculator, look at the graph, and figure out the domain and range. But why not, if you start to notice the patterns, just fill in the answers. So down here on 7, I have a cube root of x. So I know my domain and range, no matter what transformations I have. See, I have a +2 here and a negative sign. Doesn't matter. My domain and range will always be negative infinity, positive infinity. Okay? All right, let's see if we can find any others we could quickly fill in. How about number 8? Also a cube root. It has transformations. It has a 2, has a negative 3. But when we know that with cube root and cube functions, our domain and range won't change based on transformations, and it will always be negative infinity to infinity. Okay, let's see if we can find any others. How about 9? We have a cube root here. There are transformations, but we know that the domain and range will not change depending on transformations, so negative infinity to infinity, negative infinity to infinity. All right, let's see, are there any others or the rest from square roots? All right, the rest of them are square roots. All right, so let's look at our transformations. I'm going to do a few of these and let you bring the rest of them to class with you. So let's do, we'll do down here, how about for 7, 8, and 9? I want you to do the transformations for those, okay? We will do together, let's do number 1, okay? My transformation, I have a number hanging out with my x. So that caused me to have an x-axis shift. My x does the opposite of what it says in the function, so it's x-axis shift of -3. Now remember, when we talked about x-axis shifts in square root functions back on page 2 of your notes, I think it was 2. Oh, no, it was 3. Back on page 3 of your notes, remember when we have square root functions here, notice what my x-axis shift, how that x-axis shift changes my domain, how my y-axis shift changes my range. Okay? Now again, you can type these in your calculator and just look at the graph and determine your domain and range, but I want you to start seeing these, how it's affected by your transformation. So, my domain, if I have an x-axis shift to -3, that means my domain will start at -3 and go to infinity. My range doesn't have a transformation on it, so it will go from 0 to infinity, which is what it was originally. Oops, a little error here. Remember, these are actually should be brackets, okay? Because they're actually included in the line, which if you went to the table, graphed it, and then went to the table in your calculator, you would see that. Okay, let's do the next one. I have a y-axis shift. Okay, actually write this down here. Okay, I have a y-axis shift because the number hanging out by itself. Notice the radical bar does not go over that -1, so it's out by itself at the end. Y-axis shift, it does exactly what it says it does, so it's a -1. My domain won't change. I don't have an x-axis shift in number 2, so my domain will be what the parent function is, which is 0 to infinity. And my range will change based on my transformation. So my y-axis will be a -1 to infinity. Okay. All right, so let's see. Let's go on. Let's do one that's a little more complicated. How about, let's do number 5. Number 5, we have several transformations going on here. We have a reflection because we have a negative sign. It's a reflection over my x-axis. Remember, we've been saying this is a flips over my x, but really what it's called is a reflection. So that's one of my transformations. My other transformation is that I have a vertical stretch because I have a number greater than 1. So a vertical stretch of 2. All right, I'm going to write the third one up here. I also have a -2 hanging out with my x. Anything hanging out with my x is an x-axis shift. So I have an x-axis shift of +2, right? Because my x is the opposite of what the relationship says. So if it's a -2 in here, or what the equation says. So if it's a -2, then it's actual shift of +2 for the x. Okay, so I want to actually look at the graph for this one. Again, we don't have to if you start to see the relationships, but let's just go ahead and look at the graph. So we have a -2 square root of x minus 2. So go to your y equals. Yep, turn it up. Y equals, we have -2 square root of x minus 2. Okay, we'll graph it. All right, so looking at this line, the lowest value for x, this line stops at +2 on my x, and then the line continues up my x-axis forever. So my domain will be from 2 to infinity, including 2, which makes sense because we've always said when we have an x-axis shift in a square root function that it changes my domain by that same shift. Okay, so 2 to infinity. Now the range is where it gets a little tricky when I have a reflection because it flips the graph over. So if I look back at this graph, the y-axis, this graph does not go below what value. If you look at the y, or above what value, this line stops at -1. About -1. But we can look at our table and see for sure where this line ends. All right, so I want to know what my highest value is for y. Okay, so it looked like -1, but this is why it's really important to use your table. Okay, y actually does not get any lower than 0. Notice how it's error below 0. Okay, so 0 is the highest value for y, and when I say highest, because after 0, it starts getting more negative. -2, -2.8, -3, -4, okay? It gets more and more negative. So the highest value for y is 0, and then it goes to -infinity for my y-axis, or y values, which are my range, okay? So this goes, my largest value for my range is 0. It's included because we saw it listed on the graph, or on the table. And my lowest value is -infinity, okay? Because remember, it gets more and more negative as you look down the graph. All right, so for homework, I want you to finish up 6, 3, 4, all the green ones, the transformations for 7, 8, and 9. Bring those with you to class. All right, have a good night.